So now we're going to add variables. So just to review a few things. So the first thing we're going to do is if I divide 32 divided by 10, we're going to give the answer with a remainder. Now we've worked with this a few times this year. So 32 divided by 10 gives me 3, remainder 2. Because 10 times 3 is 30 and I have 2 more to go. 20 divided by 7 is 2. Remainder 6. 9 divided by 2 gives me 4. Remainder 1. Okay, so we're going to be using that when we do this part. We're also going to be using rational exponents. So remember we said if we have a fractional exponent, so say 3 over 2, the top, remember, is our exponent. And the bottom is our root or index. Okay, so we're going to be using both of these things. So we did rational exponents. I think it was the first lesson we did virtually. So let's do some examples. So this is definitely a hard section. So we're going to start with the 5th root, 7,776, and then x to the 5th. So notice now we don't just have numbers, we have variables also. So the number part, we do exactly like we just did in the last section. So the 5th root is 7,776. If we look at our chart, the 5th root of 7,776 is 6. So we start by doing that. We write 6. Now when we do the variable, so 5 right here is my exponent. 5 here is also my index. So when we are going to simplify it, we're going to write it with a rational exponent or a fractional exponent. So power exponent on top over the index. Okay, 5 divided by 5 is just 1. So 6x to the 1st for the first one. Next, we're going to do the square root of 49, x to the 10th. So remember, our index for square root is 2, although we don't always write it. For these problems, if you want to write it in, feel free. So square root of 49, if you forget, want to use your chart, square root of 49 is 7. Then when we have to do the variable, we divide. So 10 divided by 2. So 10 divided by 2 gives me 5. So 7x to the 5th. Now, so far we're starting off nice and easy because so far once we divide, we just get a whole number. So I'll show you what to do if it doesn't divide evenly in a second. Okay, let's do the 7th root, 128, x to the 7th, y to the 21st. So the 7th root of 128 is 2. X to the 7th, so we divide the exponent divided by the index. So 7 divided by 7 is just 1, so x to the 1st. Y, we have to do 21 divided by 7. So exponent over root 21 divided by 7 is 3. And then remember, if you want to write the 1 there, you can keep it. If not, you don't need to write an exponent of 1. Okay, we'll do one more easy one, and then we'll kick it up a notch. So it's 6,561, x to the 32nd, y to the 80th, and then z to the 48. So let's see if this is a perfect root. So we're the 8th root. 6,561 gives me 3. So we have 3. 32 divided by 8 is x to the 4th. 80 divided by 8 is y to the 10th. And 48 divided by 8 is 6. Okay, so those are easy ones because whenever I divide the exponent by the index, I just got a whole number. When it doesn't divide, that's how we're going to use our remainder stuff. So I'll write an example up here. We did 32 divided by 10, and we said it was 3, remainder 2. All right, so 6th root of 4,096, so that's a perfect 4th root, which is good. We can just leave it as 4. Okay, now the first one we have is x to the 18th over the index. So 18 divided by 6 is just 3. So far we just have x cubed. Then for the y, so y to the power 7 over the root. So off to the side, if you want to do 7 divided by 6, we write it like this with the number and the remainder. So we get 1, remainder 1. So the whole number is going to be your exponent out here. So it's going to be y to the first, and then leave a little space for the last variable, and then we're just going to write y to the first underneath. So this is definitely going to be a little confusing at first. Watch a few examples. So this is my exponent here. This is my exponent here. So now we're doing z to the 10th. So 10 divided by 6 gives me 1, remainder 4. So z to the first goes outside. Z to the 4th goes underneath. All right, so we're going to do the 4th root of 32, x to the 5th, y to the 8th, z to the 26th. Okay, now this is the first one. When we look at the 4th root of 32, it's the first one that we also have to break down the number. Okay, so when you're doing your work, just keep it neat because it can get a little busy. So we're going to break this down. So just like we did on the last section, the biggest perfect 4th root that goes into 32. So you're on your chart. The biggest one is going to be 16 times 2. The 4th root of 16, remember it's the 4th root, not the square root. The 4th root of 16 is 2. 4th root of 2. Okay, so that's just the number. So we're going to leave the 2 out front. We're going to leave space for the variables, and we're going to do the 4th root of 2. And make it nice and big because there's probably going to be some more stuff you have to add under the radical. Okay, now we're going to do the x's. So 5 divided by 4 gives me 1, remainder 1. 8 divided by 4 is just 2, so that one we just have a 2 come out, nothing's left over. Gotta make this a little smaller. Now z, so 26 divided by 4 is 6, remainder 2. So I'll do that again. 26 divided by 4 is 6 remainder 2. So if you want to have like kind of paper off to the side to divide, you can do that. So 26 divided by 4 is 6 remainder 2. Because remember, 6 times 4 is 24 plus the 2. Let's do negative 875, x to the 7th, y cubed, z to the 17th. So try this one on your own, see if you can get at least part of it. Okay, so cube root of a negative. So remember, it's okay because we have an odd index. So we go over here, cube root, we don't see the number, so we have to break it down. So the cube root, remember we take the negative out right away. Negative 125 times 7 is what gives me negative 875. So we got negative 5. We're going to leave some space for the variables. And 7 stays under. So 5 comes out and 7 stays under. All right, now for the variables. So 7 divided by 3 gives me 2 remainder 1. 2 remainder 1. So 7 divided by 3 gives me 2 remainder 1. Next one, we have y cubed. So 3 divided by 3 is 1, so that's just y to the first. Nothing's left over. Okay, next one is 17 divided by 3. So 17 divided by 3 gives me 5 remainder 2. So 17 divided by 3 gives me 5. 5 times 3 is 15, so remainder is 2. So the 5 is the exponent on the outside. The 2 is the exponent that stays underneath. So 5 come out, and then 2 are left underneath. Okay, so now we got the 4th root of 162. So over here, it's not in our column. We have to break it down. So we do 81 times 2. So 4th root of 81 is 3. Leave some space for the variables. 4th root of 2. 2 stays underneath. Now we're dividing. 6 divided by 4 gives me 1 remainder 2. So x to the first comes out, x squared stays underneath. Next we got 7 divided by 4. 7 divided by 4 gives me 1 remainder 3. So y to the first comes out, y cubed stays underneath. Last one, z to the 12th. This one's nice. 12 divided by 4 is just 3. So we leave that, and then nothing has to go under the radical. So our answers look a little crazy when we're done, but that's our answer. Okay, and again, make sure your index is nice and small so it doesn't get confused with the exponents. Okay, so square root, again, if you want to write the index in, the index is 2, although it's not going to be written. So square root of 20, it's not in our column, we got to break it down. Square roots should be nice and easy. We did a bunch of square roots. So biggest perfect square that goes into 20 is 4 times 5. So we have 2 outside, leave some space for the variables, and 5 stays underneath. Okay, now we're dividing. The exponent 2 divided by 2 is just x to the first, nothing's left over, no remainder. 9 divided by 2 gives me 4, remainder 1. So y to the 4th comes out, y to the 1st stays underneath. For z, we have 11 divided by 2, which gives me 5, remainder 1. So z to the 5th comes out, and z to the 1st stays underneath. Okay, so 384, x to the 15th, y to the 12th, z to the 39th. So 7th root of 384 doesn't go into it evenly, so break it down. Okay, so 7th root of 128 is 2. 7th root of 3. Now we're dividing. 15 divided by 7 gives me 2, remainder 1. 12 divided by 7 gives me 1, remainder 5. 1, remainder 5. And the last one, we got 39 divided by 7 gives me 5, remainder 4. So z to the 5th outside and z to the 4th underneath. All right, last one, we got the cube root of negative 56, x to the 7th, y to the 1st, z to the 20th. So if I were to break this down, we have negative 8 times 7. So the cube root of negative 8 is negative 2. Leave some space. 7 underneath. 7 divided by 3 is 2. Remainder 1. Now, when I try to divide 1 divided by 3, if it doesn't go into it at all, then y to the 1st just stays underneath. Same thing if it was y squared. 2 over 3, 3 doesn't go into the number, so it just stays underneath. You can't do anything else with it. 20 divided by 3 gives me z to the 6th outside, and then z squared.